come now to the topic in power plant engineering. So this is hydroelectric power plant. Okay, so this is the first part of the presentation class. Okay, so we have here hydroelectric power plant. So it's a facility at which electricity is produced by hydroelectric generators. Okay, so we have here for letter A, so medium and low head plants. So for medium and low head plants, the types of turbine that is utilized is the reaction type, okay, or the reaction turbine. Okay, so for medium head plants, the head here is 30 to 100 meters. So the turbine is of course the Francis turbine. Okay, so purvey provided at the beginning of penstock at the reservoir. Okay, so water is carried in open canals from main reservoir to purvey, then powerhouse through penstock. Okay, so here is class the illustration of the medium head plants. Okay, so another we have here the high head plants. So the turbine used for high head plants is the impulse turbine. Okay, so the head is from 100 meters to 2,000 meters. So water is stored in the lake over the mountain during high rainy season or when snow melts. Okay, so the turbine of course is the Pelton wheel. Okay, so this is the type of turbine that is utilized for high head plant. Okay, so we have here some definitions of the hydroelectric power plant. One is of course the reservoir. Okay, so it stores the water coming from the upper river or water pools. Another is the headwater. So this is the water in the reservoir. So the level of the water in the reservoir. Okay, spillway. So is aware in the reservoir which discharges excess water, so that the head of the plant will be maintained. Okay, another is the dam. So concrete structure that encloses the reservoir. Okay, valve. Okay, this is device that opens, stick, and or closes the entrance of the water into the penstock. Okay, another is truss rack. So it's a screen which prevents the leaves, branches, or other water contaminants to enter the penstock. So another way of the penstock, of course, this is the channel that leads the water from the reservoir to the turbine. Okay, so take note class of the definitions. Okay, so another we have also surge chamber. Okay, so it's a standpipe connected to the atmosphere or attached to the penstock, so that the water will be at atmospheric pressure. Okay, we have generator, tail race. Okay, tail race is a channel which leads the water from the turbine to the tail water. Okay, and another is the drop tube. So a device that connects the turbine outlet to the tail water so that the turbine can be set above the tail water level. Okay, so let us now go to the performance of hydroelectric power plants. Okay, so first we are going to determine what is a gross head. Okay, so gross head is the difference between the headwater and the tail water elevation. Okay, so or HG is equals to headwater minus the tail water. Okay, so another we have here the friction head loss. Okay, so we have here two formulas that can be useful in computing the friction head. Okay, so friction head loss is the head lost by the flow and a stream or conduit due to the frictional disturbances set up by the moving fluid and its containing conduit and by intermolecular friction. Okay, so we have here the first is using the Darcy-Weisbach equation. Okay, wherein the formula is easy. So that is FL B square over 2GD. Okay? And another, we have the Morse equation. So, the formula is quite similar. Okay? So, we're in the Morse equation, the 2 at the numerator is uh, now at the numerator. Okay? From the denominator to the numerator. But take note, class, that when you use this equation, Morse equation, you have to use the friction constant, or F, from the Morse table. Okay? So take note of that, class. Okay? So another is the net head. Okay? So the net head is, of course, the effective head, or is the difference between the gross head and the friction head loss. Okay? So the net head is gross minus HF. Another is the penstock efficiency. Okay, so we have here the net head divided by the gross head. Okay, so volume flow rate of water. So this is the product of the velocity and the cross-sectional area. Okay, so that is Q is equals to area, cross-sectional area of the conduit, or the penstock, multiplied by its velocity, is now your discharge. Okay, another is the water power. So uh, this is the power generated from an elevated water supply by the use of hydraulic turbine. Okay, so the power now is equals to the unit weight of the water multiplied by the discharge multiplied by the change in elevation. Okay, so another is the turbine efficiency. So the turbine efficiency, of course, is the turbine power divided by water power. Okay, electrical generator efficiency, generator power divided by the turbine power. Okay. Another, we have the synchronous speed. Okay, where n is equals to 120 f, the frequency divided by the number of poles. Okay, and the hydraulic efficiency. So we have here the HW over the net head. Okay. Okay. So head of impulse turbine. Okay, so we have here H is equals to P over gamma plus B square over 2G. So in computing the head, of course, we have here the pressure head plus the velocity head. Okay, so head of reaction turbines, or Francis, or the Kaplan type. Okay, so we have here the pressure head multiplied by the elevation head plus the velocity head. So another, we have here the peripheral coefficient, or the, yes, okay, so that is the velocity of the runner divided by the velocity of the jet. Okay, so that is pi dn divided by square root of 2gh. Okay, so another specific speed of hydraulic turbine. Okay, so in English, that is n square root of the horsepower divided by h raised to 5 over 4. Okay, so in English, that is 0.2623 multiplied by n multiplied by the square root of the kilowatt, or the power, divided by h raised to 5 over 4. Okay, so for the total efficiency now, so that is multiplied all the efficiencies: hydraulic efficiency, mechanical efficiency, and the volumetric efficiency. Okay, thank you very much, class. So that's all about the discussion of the principles used in the hydroelectric power plant. Thank you very much, class.